it.
Just put a 4 in.
Okay, these first two we can do in decimals. The last one we really don't need to use decimals.
Oh. Okay.
I've already done. So what we did the other day with evaluating, you could put in the equation. Sorry, I was talking now. And make the x's capital. Add the slider of x and then make x3. You should get 7.
I put 7?
Or you could put 7 in as parentheses.
But like that takes longer.
It's like you could never be wrong.
But like no one. But like, what are you talking about? I'm not arguing. I'm not arguing. Okay, but then I changed it. I was like, oh, it is 7.
I'm not arguing.
So either way, you should get 7.
I never said that.
Questions on that first one?
That's it. Yeah, what was the answer?
7.
Okay, yeah, I got that.
Alright.
And then you could have put all of these in to see, did they form a line, did they form the hyperbola, or something else? So if I put in all of these points really fast, -2, 4.
It was neither.
But like, why? Is it easier to put it on the table?
I knew it was neither because something times 0 is 0.
Yes, no, it doesn't really matter.
What's it not be?
You could do that. Here, if I did that. So either way, you could either put in the set of order pairs. You could actually put them in all at once, or you can put them in a table.
Oh, say.
So as is, these definitely don't make a line, and they don't make that hyperbola shape. So neither. And then for the last one, the equation of the line whose slope is 4 and y-intercept is 9. You're given both your slope and y-intercept, so 4x minus 9.
Who got that wrong?
Questions on those things? Look at your notes.
There's so much paper. Look at all the trees.
They're already dead by the time it gets to my hands.
Okay.
Go ahead and write this down. Compound inequalities are 2 inequalities or more. We're only going to deal with 2 though. That are joined together with the words and or the word or. And or inequalities have a tendency to graph apart.
Is that so hard?
A few years ago, yes. Now that you can use decimals, no. 70 to 85% of the questions can be used solved on decimals alone.
Oh. Okay, let's say we don't know how to use that.
That's what she's teaching us right now.
Oh,
What's that part?
that makes sense.
Okay. And then talk about the ands. Possibly negative, that might be a small thing. We'll see. So when you have an or inequality, at the end you get two separate answers that'll look something like this. You're going to graph both of them on the same line. So this one would be closed at -2 going to the left. This one would be open at 3 going to the right. So when it says it graphs apart, they're facing away from each other. Then the interval notation, you're reading this left to right. So this would start at where? Negative infinity. Yep, so parentheses, negative infinity, bless you.
Oh, thank you.
It would stop at -2, and it's closed, so bracket. Then you would put the word or, start again at 3, but it's open, so parentheses, and then it would keep going towards infinity. What was that? Questions on that piece before we get into the actual solving? Okay. I will say, on Delta Math, when you do this assignment, the problems will be set up like this, two separate inequalities where you have to solve them. Sometimes they'll be graphed apart like this. Sometimes they may graph on top of each other, but you're looking at from left to right, what is it saying? What is it reading? You would just look at the graph entirely. From left to right, what does it look like? If you need help with that, let me know. Okay, so for number 1, we're going to solve both inequalities separately. What you do to one, you don't do to the other, so solve them as two separate inequalities. So for this one, we would do what?
Minus plus 5. I mean,
Plus
4.
Plus 4, there we go. And then for the other one,
-2.
Divide by 2.
divide both sides by 2. Once you have both of your inequalities, put the word or in between it. Even if your inequalities, like one piece is over here, one piece is over here, still write the word or, draw arrows in between them. That word has to be in between. Then draw both of those. So you'll have one that's open going to the left, one that's closed at 6 going to the right. How would we write that interval notation?
6.
Negative infinity, parentheses, negative infinity, to -3, parentheses, or bracket. Parentheses. Then the word or. What?
Oh.
The next part?
6.
6, bracket or parentheses.
Bracket.
And then it ends at
Infinity.
But why did you make both black here?
because this one is closed and this one is open. Open gets parentheses, bracket gets, closed gets bracket.
But like on the other one, you did bracket to the other side. Because it's black.
Because this one was closed.
Oh.
There's gonna be one point that we are gonna have both with numbers.
Yes.
So I can't draw
And these are your ends. Your end inequalities. Do we have other questions on number 1 before we do? We're going to skip 2 and go to 3. Okay.
Oh my god.
For number 3, let's go ahead and solve that one.
What is
Subtract 9 for this one. So we have 2x is greater than 8. Divide both sides by 2. And then solve the other one. Subtract 10 on both sides.
Oh, okay. I'm so cute.
Keep going. Divide both sides by 5. So that x is less than 0. If you want to rewrite this so that it's in the order that you graph it, so that the less than is on this side and the greater than is on the right, you can do that. You don't have to. Go ahead and graph those.
I'm still minusing 3.
And then we would write that interval notation like negative infinity parentheses
0
to 0 parentheses or bracket.
parentheses.
Then the word or parentheses or bracket. Parentheses 4 to infinity parentheses. Questions on that one? Okay, let's do 5. For this first one, we can either distribute the negative 3 or divide both sides by negative 3. Which would you rather? Okay. If you did choose to divide, your sign would flip. It doesn't matter either way. You would get the same answer. So let's add 3 and divide both sides by negative 6. Remember to change your signs if you're dividing by a negative.
So when we're dividing, we change it. We change that.
When you're dividing by a negative, not in general. Alright, and then to solve the other one.
Minus 1 to both sides.
We have negative x is greater than or equal to 4, and then
Divide by
divide by negative 1. So the sign changes. X is now less than or equal to negative 4.
Yeah.
And then graph those. X is greater than 2 and less than or equal to negative 4. So how would we write that interval notation?
negative infinity. Negative 4 bracket.
Negative 4 bracket. 4. Parentheses 2 to infinity. So, or inequalities aren't much different than just solving inequalities in general. You're just doing 2 of them, graphing them both on the same line, and they graph apart. Any questions on or inequalities? Now go on to the back. We talk about and inequalities. So everything we just did is now going to be the opposite. Instead of solving it separately, graphing it apart, now we're going to solve it together and graph it together. So everything has a tendency to graph together. So if I got something like this, where we get x is greater than or equal to negative 6 and x is less than or equal to 1, we can go ahead and graph both. I'm going to show you what happens though. The lines overlap. So we are really just looking at where do they overlap. So you could still graph these two, but your end graph should look like this. So whether you have all 3 or just that one, you need at least the one where it starts at one point and ends at one point. So that's it. That is your and inequality. That is where they overlap. Okay. And then when we write the interval notation, we're looking at where does this start or where does this end. These are both closed, so both brackets. And we disregard that they kept going towards infinity. Questions on that?
How do we know if it's an and inequality or it's an or inequality?
So we're going to get into some problems, but it'll look different. One will say the word and or. The other won't. for mine, but on Delta Math, they will say and or. Last thing for this, so because the and falls between two endpoints, I'm going to rewrite this down here. X is greater than or equal to -6, and x is less than or equal to 1. Instead of writing it like this, we're going to write it in a condensed format, where you take the lowest and the highest, your signs become less than or equal to no matter what, and then there's an x in between. So this reads, your solutions fall between -6 and 1. It could be all the decimals and fractions in between. It could be all the whole numbers. It could be -6 and 1. But it's all of those numbers. And when we solve our inequalities, they're going to be in that format so that we can have that as a final answer. But I'm also going to show you how, if you wanted to solve them separately, you can do that. So for number 6, if we were to solve this, we're trying to get x by itself in the middle. So get rid of 4, but subtract it to everything, to all the sides. And then you could either just graph from -2 to 5, close at -2, open at 5, and draw a line between it. Or if you want to see that these did overlap, you could look at just half of it. X is less than 5, so start at 5, draw your arrow to the left. Look at the other half, but read it backwards. X is greater than or equal to -2. And you could see that it overlaps at that place. Also, if the condensed format is confusing and you want to separate them, you could cover up half of it and solve just this part, and then cover up the other half and solve just this part. Solve them separately, but at the end, your answer needs to be condensed. So whether you solve them separately or together, your answer needs to be condensed. Yes?
Like, what would you do if there was a greater than sign and a less than sign? Like, how would you, what the sign happen? Like, what if the signs were different?
Like,
It was like for example, the power, the side was this one.
in Delta Math, you will see them as two separate things, but no matter what, at the end you put least number. We haven't done the implementation either. But you put least number, and then the greatest number, and then you put x in the middle, and you just change it to less than, or less than, no matter what. It reads the same thing. This is saying that x is between -6 and 1. It's greater than -6, but it's less than 1. It's saying the same thing.
Oh, so would it matter? Okay.
Alright, what would the interval notation of this be? Bracket -2, and then 5 parentheses. Sometimes you'll have a mixture, sometimes you'll have 2 parentheses, 2 brackets, it depends. Other questions on inequalities? Let's do one more and then we'll be done for today. Finish the last one and the rest. Let's do 8. So add 4 to everything. And then divide 3 to everything.
We don't add it to the x.
Add what to the x? We're trying to get that out of the middle. So we want to get that out of the middle. Now, if you had a -3x instead, all of your signs would change. I'm just going to make up an example where that is the case really quickly. signs would change direction. But when we write it with and, it always has to be less than or less than or equal to. So we're going to take this whole thing and flip it so that the least number is over here. And you would rewrite it. So always less than or equal to or less than, no matter what. Go ahead and graph that. If you want to draw the arrows, you can. I'm not going to do that. And then what would the interval notation be?
Negative 4
Bracket.
and then 2 bracket.
Yes. Hold on to this because we're going to finish it tomorrow. You guys can put iPads and calculators back.